Hi, my name is Bob Tabor with LearnVisualStudio.net. In this video, we're going to get back into writing code. We're going to learn about declaring and using variables. So let's start off with a really simple example. You've probably seen a simple problem like this before, right? 5 plus x equals 7. You can figure out the value of x without a whole lot of thought. Well, using that same thought process, take a look at this little passage of code. X equals 7, y equals x plus 3, console.writeLine the value of y. Now, if you were to run this application, what would you expect to see pop open in the little console window? The value 10, right? Well, you can read C# code on your own. It's that simple. All right, well, obviously there's a little bit more to it than that. So let's go ahead and break this apart. First of all, what do you call y and x in this context? They're called variables. And a variable is simply a bucket in your computer's memory to hold a value. You can put stuff in the bucket and read stuff out of the bucket. You can even put new stuff in the bucket to cover up the old stuff, all right? So in this case, these buckets, these variables, are holding numeric values. But we can create buckets that are just the right size to hold any type of data, whether that be dates and times, strings, passages of text, or really big numbers, or numbers that have values after the decimal point. Now, in the case of our little code snippet here, we expect both x and y to hold numeric values. Now, we know that, but we have to use C# to express that to the .NET Framework runtime. Now, remember that the runtime is what actually does the hard work of allocating a space in memory for our data and then managing that reading from and writing to the memory within the computer. So here we have two data items, and we have to tell the runtime to allocate some space in memory sufficient to hold numeric data. So let's go ahead and start writing this application, and we're going to start breaking it apart, adding more to it. But in a nutshell, that's the notion of variables, buckets in memory. Okay? So let's start off by creating File, New Project. Make sure on the left-hand side you have C# selected and console application in the middle, and then we're going to change the name to variables and then click the OK button. Alright, and what we want to do is write some code between this open and closing curly brace. So here again, a couple of things. The only way you're really going to learn how to write, to learn how to code, is to actually get your hands dirty and follow along and write code. It's the best way to learn. And then secondly, all the same rules from before apply now. You're going to have to type this out exactly. If you don't, you're going to experience some errors, some red squiggly lines. When you try to run the application, it's not going to work. Please refer to the video that we covered this on, the Hello World application, a couple of videos ago. Okay? So follow along, rewind, pause if you need to, but follow along as best you can. Okay, before we move on and actually attempt to run this application, let's talk about what each of the lines of code do. First of all, the first two lines of code, int x and int y. So to borrow from the earlier explanation in this lesson, we're asking the .NET runtime to allocate space in the computer's memory to store two numeric values. One we're going to call x and one we're going to call y. We're asking it to create two buckets that will hold values that we will drop into them in just a moment. So after we've created the buckets, after we've created the variables, we can begin to assign values into those variables. And most importantly, notice that we are dealing with a specific type of value called an integer or an int. So int is the C# term for the word integer. It's a mathematical term that refers to a number that has no fractions or decimal values. In C# or rather in .NET, it can contain relatively large numbers from a negative 2,147,000,000 to a positive 2,147,000,000. Now, if you need to store a larger number, or if you need to store a number that has decimal values or any other kind of value, you're going to have to use a different data type than integer. And we'll do that in just a moment. So to continue the bucket analogy, if you need to store a bigger number, then you're going to need to create a bigger bucket in memory. Okay. So after we declare the variables, then we can access the variables, assigning values into the variable or reading values out of the variable. And we did both in the following two lines. Here in line 15, we're taking the value of x and assigning it the value of 7. In the following line of code, we're going to read that value back out of memory, so 7 plus 3, and assigning that to the value of y. Notice that the equal sign operator will perform the assignment operation. Furthermore, we're using the plus symbol, just like we would in a mathematical equation, to do addition between two or more values. All right, so that is what we're doing there. And then finally, we're going to read out the value of y now from memory and then pass that to the write line method that we're already familiar with from the Hello World application. So now let's save our work. I hit the Save All button on the toolbar. Opening up the Save Project dialog, we're just going to click the Save button, accepting all of the default values. And now we're going to start debugging the application. And indeed, we see the value 10. Okay. So now let's comment out these lines of code. I'm going to use that multi-line comment syntax. So asterisk, forward slash asterisk. And then I'm going to go to the bottom line of code right before the read line and type in asterisk slash. And that will now comment out these lines of code, meaning that they will not be compiled into the .NET assembly. We will ignore these lines of code. Now we still want them here for reference, because if you want to open up this and follow along, you'll want to see what I typed. So that's why I'm commenting these lines of code out. I typically do that instead of just deleting lines of code until I'm 100% sure that the new code actually works. Okay, and we'll come back to that notion a little bit later. So what I want to do is create a second example using a different data type. So follow along again, please. And let's go ahead and run the application. And we can see that it's really no different than the Hello World application. The only difference here is that we are using a variable to store the value instead of just hard coding the value into the write line method itself. All right. So notice that the string here, that word is a keyword that creates a bucket in memory that can hold textual information. It can hold alphanumeric characters. Also notice that I can name my variables anything I want. X, Y, my first name, my last name, whatever I want. However, I'm also using a naming convention. It's just a convention that programmers follow. You can call them whatever you want, but you should follow what other programmers do. In this case, we're using something called camel case, where we start with the lowercase m for my, and then an uppercase F and an uppercase N. So every subsequent word that we use in our variable names will have an uppercase letter. And the reason is for readability. We'll talk about the reason for the lowercase m a little bit later when we talk about scoping and things of that nature. Let's just pass by that at the moment. So now we have two variable types under our belt. We have integers and strings. Now there's probably a dozen different variable types, or data types rather, that you're going to want to know eventually, and we'll probably come across a few as we continue on this video series, and then obviously as you continue your C# education. But at any rate, we already ran the application. We saw that it worked. One thing that I want to point out here is that C# is a case-sensitive language. So if I were to go to the line before this and type in my first name, all lowercase, notice that this application would still run. We get no errors. And the reason is because C# or .NET Framework runtime considers these two different variables. Now that can cause some confusion if you were to create two variables that have a very similar name. The only difference is the capitalization. Strongly recommend that you don't do that. Always know why you're doing what you're doing. So in this case, we would want to get rid of this. But I want to point out that those are two different identifiers within C#. All right, so let's move on. I'm going to comment out these two lines of code, and I want to explain that we can do really both of these operations in one line of code. So string my first name equals Bob. Okay, so here we're declaring a variable and initializing its value all in one line of code. And the reason is because experienced developers like to write less code. So they're always looking for a convenient way to reduce the number of keystrokes that they have to type and reduce the amount of code that they need to look at and understand. So you should get into a practice of doing this as well. Using one of the techniques that we used earlier, let's comment that out and even move on beyond that to one more example that's very similar. In this case, var my first name equals Bob. All right, so this takes a little more explanation. Several years after the C# programming language was developed, a few innovations were added to the programming language to reduce the amount of code that you had to type. And there's a long story behind why the var keyword came about. And I imagine you're going to see the var keyword whenever you look at examples on MSDN or through other blogs and things of that nature. So it's important that you understand what var is used for. The idea is this, that the C# compiler is smart enough to see what you're initializing that new variable to contain. So why not just let it figure it out? Why do we have to go to all the hard work of figuring out the data types? All right. In this mundane example, doesn't make a whole lot of sense. When we get into some more complicated examples like we will later on in this series, you're going to see why this makes a lot of sense. It's important to know that in this case, the variable my first name is of data type string. It's not an unknown data type. Once we declare my first name using var and initializing it to the value Bob as a literal string, it can never hold any other type of data than a string data type. So it can't hold a number or a date time or anything else. It has to hold a string from that moment on because it realized when you first initialized it, it was trying to be a string. Okay? Just keep that in mind. You're going to come across the var keyword. Don't be too confused. It's just a shortcut for experienced developers, a shortcut that you'll become more familiar with much later in this series of lessons, but I want to point it out to you now if you're looking at other examples on the internet. Okay? So now let's move on beyond these simple examples and move into talking about type conversion. This is when you need to change a number into text, string, and vice versa. What do you do? How does that work? Well, that's actually a big issue within .NET, and so there are several ways that we can go about that. So let's comment out these lines of code and start below that. And I'm going to start with this example, int y equals 7, string y equals Bob. So we have two different data types here, an integer and a string. And now let's do something crazy and try to add those together. All right. And even, let's go as far as to write that out to console window, my first try. What do you think we'll see here? Let's run and find out. 7 Bob. All right, why is that? What happens here is that there is an implicit data type conversion. First of all, we're trying to create a variable called my first try of type string. So we're going to take Bob, the value of y, and we're going to concatenate that to whatever's in the value of x. So the plus operator is no more an addition operator. It's a string concatenation operator at this moment because we're working with a string. Okay? So it changes its meaning based on its context. In this context, we're trying to concatenate strings together. Now, the value 7 is a number, and it's not a string, so it can't be concatenated together with another string. And implicit data type conversion has to happen. So behind the scenes, what is going on is this. All right. Whoa. X is going to be converted to a string using this .toString method. Now, why this is and how is it available, on this variable name, we didn't declare toString anywhere here. We just did int x because all integers have this toString method. We'll talk about this a little bit later. It's actually kind of an advanced concept. Just accept the fact that it exists for now, okay? But now we're doing an explicit data type conversion. We are explicitly saying you must convert yourself to a string in order to be concatenated to another string in order to properly print out to screen. So when it can, C# and the .NET Framework will do the conversion for you. Having said that, you should never rely on implicit conversions. You should always take control of your code and make sure that you are explicitly converting when you know you need to. Okay. So now let's do this. Let's comment out this line of code, and right above it, we're going to do the opposite. We're going to do int my second try equals x plus y. Okay. Now when I do that, just a moment later, we're going to get a red squiggly line. I'm going to hover my mouse cursor over it, and it'll say it cannot implicitly convert type string to int. So while it was easy to take the numeric value of 7 and make it into a string value of 7, it is not possible to take a string value Bob and convert it into a numerical value Bob. Okay, it can't be done. The C# compiler says, whoa, you are just you're trying to accomplish something that I don't know what to do with it. So it'll give you a compilation error. What we can do, so if we were to even try to do console.writeLine, we're going to just butt our head up against a wall. So let's try to run the application, and it won't get far. All right. Pop up the error list, cannot implicitly, just like we saw before. Okay, so how do we remedy this situation? Well, I'm afraid that you cannot remedy this scenario because there's no explicit conversion from Bob into a numeric value. But what if we were to do this? What if we were to attempt to convert 5 from a string into an integer value? That's possible, but we still are going to get an error because .NET says that we don't know what this value is that you have here in this literal string. There's no way for us to know ahead of time, so we're just going to disallow this. You, again, need to do an explicit data type conversion. So what we're going to do is int.parse, and again, just accept this at face value. I don't want to explain how this is even possible that you're able to use the int keyword and do .parse on it. Just memorize that syntax for now. Later we'll explain how this is even possible. So if we were to do that, we may still see some residual problems here, but I have an idea that this is going to work. And it does. So 5 plus 7 equals 12. We're able to add these two values together through the use of an explicit data type conversion. Now let's do one more thing, and that is I'm going to uncomment out that previous line of code. My first try should print a screen, and then my second try should print a screen. So let's run the application, and now we can see the difference in the two techniques. In the first case, we're concatenating the value 7 and the value 5 together as two string values. In the second case, we're taking the value of 7, the numeric value of 7, and the numeric value of 5, and adding them together, giving us the value 12. Okay, so hopefully that makes sense. The key idea in this lesson is how to declare and initialize and work with variables and data types. In the .NET Framework, even simple data types like the int have some powerful helper features to convert one data type into another data type whenever you need. We're going to build on this idea as we move forward, so we'll see you in the next video. Thank you.